Our lesson today is about solving quadratic functions. We're going to talk today about several methods for solving, any one of which is correct to use at any given time. One of the things that we'll try and help you to do, though, is to find which one might be best for a given activity. So we're going to begin with trying to solve a quadratic by graphing. And as you can see, I have asked my calculator to do a table of values for this quadratic, 6x raised to the second power plus x minus 2. I'm going to plot the points that it's telling me, and I'll tell you that these are estimates. It's rounding to one decimal place, so it's not going to be exact. But when x is -1, y is 3 in this. And as you look at the graph scale, that puts that point right around there. When x is -1/2, y is at -1. When x is 0, y is at -2. When x is 1/2, y is at 0. And when x is 1, y is at 5. And then it continues to grow. I see there at 1.5. X is all the way up to 13 by then. So this is a quadratic function. It's tempting to think that the vertex is here at the lowest point we've plotted, but that's not true. It technically is down here somewhere. This quadratic, or this graph, is going to be very much an estimate, and trying to decide which values for x contain the roots or the solutions to this quadratic is going to be difficult, because at best we're estimating. Now, one of them we can tell pretty straightforward right here. If we're seeing a value of 0 at a given x, that's probably a root in this quadratic, okay, where it crosses, or a solution where the x that makes y 0. So a solution to the quadratic, one of them is at 0.5 or an x of 0.5. And we're not quite sure, so I'm going to say about equal to. The other is over here in negative territory somewhere, but since I already know that this graph is not symmetric, I don't even want to guess at 0.5. I just know that it's somewhere between -1 and -0.5. In fact, it looks like it's be closer to -0.5, so we might make a guesstimate of about -0.6 maybe, and that is really just a guess. That's one of the things that I'd like to talk about here. One of the disadvantages of using a graph to solve a quadratic is that you often have to estimate. It's not very often that you will get exact answers from a graph. One of the advantages of it is that it's familiar to us. We're used to graphing from our algebra classes. I'd like to also take this one step farther and tell you that a definite advantage is that you can use your graphing calculator, which is a godsend. I'm going to flick to the next page here and show you what I've done. In my graphing calculator, I input the function, I asked it to graph it, and one of the preset functions on the calculator is finding the root or solution. And so you can see we were absolutely right over here. One of the roots is at 0.5. The other happens to be almost, well, it's -2/3 is the way it comes out, or -0.667 to the estimate. We couldn't have gotten that accurate by our pen and pencil drawing. However, the calculator is designed to do that, and in our next class meeting we'll show you how to do that on your calculator. I'm going to flick back here for just a moment and say that that is a big advantage. You can use your graphing calculator. One disadvantage, however, we got to give fair and equal treatment here, is that some quadratics don't have roots. And I want to just have you sketch an example like that. Some don't have roots. That would be something that looks like this. A root or a solution is where it crosses the x-axis, and it's possible that you can have quadratics that never cross the x-axis. So graphing can't be used to solve every quadratic. let's move on, and I'm going to go quickly past my graph screen here and say again, we'll show you a little bit more about that tomorrow. A second method for solving quadratic equations is to use factoring, and this is one that we're familiar with from our work in algebra. This quadratic happens to have a coefficient of 2 out in front. Some folks would say that wouldn't be their favorite to factor, but I would say with the box method, it's just as easy to do this one as one that has a coefficient of 1. I'm going to go ahead and draw the box method. And remember, when you're factoring, these are the two terms that you know for sure. They fill in these corners in the box. So we have a 2a squared and a minus 21. Then the idea is we use the x to help us. Coefficient here is negative 21, here 2. So 2 times negative 21, negative 42 goes on top of the x. We have to have things that add up to 11, and so we got to think about what goes into 42. 6 and 7, that's not going to help us get to 11. I know that 3 goes in here, and I'm going to cheat and just tell you that I know that that's the right factor for us. I want to ask you to think about that quickly. How many times does 3 go into 42? 14, I believe. And if you think about this, we have negative when we multiply, positive when we add. That means that has to be positive and that has to be negative. We are not done factoring this, folks, and this is the place where we sometimes get hung up when we're using the Xbox method to factor. Instead, these are the numbers that go in these corner boxes. So negative 3a and 14a here. Then the idea is you take the greatest common factor out of a column or out of a row, doesn't matter which way you start. I'm going to go column and say that a is the biggest thing that both of these have in common. That means that this must become a 2a, because in order to have that 2a squared, row times column has to equal that. And let's see, we'll burn through the rest of this. 2a goes into 14a 7 times. And here, a goes into negative 3a minus 3 times. So here come our factors for this. 2a minus 3 times a plus 7. All of that has to equal 0. Remember, we're solving this equation. We are not just factoring it. So if you think or remember about the zero product property, it says that if two quantities are going to multiply to make 0, then one or both of them have to be 0. So we're going to say, okay, one or both of them have to be 0. So what if 2a minus 3 is equal to 0? Well, if we solve this for a, we'll know the root or the solution to this quadratic. So solving for a, we'd add 3 to both sides and have 2a equals 3. Dividing by 2 would give us an a of 3 over 2, or 1/2. It's also true that the other parenthesis or other factor could equal 0, so a plus 7 could be equal to 0. Solving for a here means that a could be negative 7. So we have two solutions for this. A is equal to either 3/2 or negative 7, and both are correct. Okay. Solved by factoring. As far as advantages to this one, what students have told me in the past, again, this is quick if you know what you're doing. And many algebra students do know what they're doing, and so they would say this is easy. It is also, I'm going to write on here, familiar. It's not something new that we have to learn. Disadvantages, there are math errors, of course, that could be made. That always is true. But more importantly, not all quadratics factor. So this doesn't work all the time. And ideally, we'd want a method that works all the time. So let's take a look at a method that does exactly that, one that does work all the time. And that is called completing the square. You probably learned this method in your Algebra 2 class, but if you didn't, we're going to go through the steps very carefully today and hopefully give good explanations so that you'll know why we do what we do. The idea is we want to make one side of this look like one of those perfect square trinomials. That's something that has x minus number quantity raised to the second power. Because if we do that, then we can take a square root and we'll work it out from there. In order for us to do that, though, here's the plan when you're completing the square. You want to keep these two terms on the left side of the equation and shoot any constant over to the other side. So here comes my first step. R squared minus 4r, and I'm going to do something that looks weird here, plus a blank. I don't know exactly what's going to go there. On the other side, negative 10. I moved it from one side to the other, so the sign changed. And I got to tell you, completing the square, you're going to add something to both sides of this thing. Got to be the same thing to keep equality, and that's the goal when you're solving an equation. So then the question becomes, well, what exactly do you add? And here we're going to give you a rule. What goes in the blank, if we're considering a quadratic to be written in this form, ax squared plus bx plus c, what goes equals 0. What goes into the blank there is b over 2a raised to the second power. B over 2a raised to the second power. In this particular quadratic, that's negative 4 over 2 times 1. A is 1 in this one. So over 2 squared. Now I'm going to leave it that way here because this makes a little bit more sense to me. Over here, I'm going to know that negative 4 over 2 squared, well, negative 4 over 2 is negative 2, and negative 2 squared is 4. So we're really adding 4 to both sides of this equation. My next step, I'm going to just do a little simplify here. R squared minus 4r plus negative 2 raised to the second power. I like this format better, equals negative 6, and I'll tell you why. Because right here we have the perfect square trinomial format. That is, this middle term is the square root of this one, negative 2 times 2. And the reason that we complete the square is so that we can go from this trinomial format to what we know is equal to it. That is, that perfect square trinomial boils down to this, r minus 2 quantity squared. I want us to just think about that again. Remember, the factoring pattern says you take the square root of this, you double it, and if that's the case, then that boils down to square root of this, square root of this, used twice. And that's exactly what we've done. We've put this into a more convenient form for us. The reason that we do that is because now, folks, we have something that's squared. We can take the square root, and that's exactly what we're going to do. So we're going to take the square root of both sides, and we're going to say that r minus 2 will be equal to the positive or negative square root of negative 6. And some of you are going to be thinking, whoa, you can't have negatives under there. And I'm going to say, you know what, you're absolutely right. This is not a real number solution. It's going to be a complex number. And I hope that you will recall that when that is the case, that square root of negative 6 radical, this is our thinking. That's a 6 times a negative 1 there. And negative 1 is defined to be I. And that means that we can write this side as positive or negative I times the square root of 6. All that's equal to r minus 2. And we like this, but what we really need is r. So let's add 2 to both sides of this equation. R will equal 2 plus or minus I times the square root of 6. And there are 2 solutions, 2 plus this value, 2 minus this value. Just a reminder that those imaginary roots always come in pairs. Always, always, always. Like our 2 plus I root 6 and 2 minus I root 6. I hope you remember that completing the square from last year. It's an excellent tool, especially when you start graphing quadratics. It's a wonderful tool to use. However, for us, the advantage is that this works every time. There is no quadratic that cannot be solved by completing the square. The disadvantage is that it's a sometimes unfamiliar procedure. which means that we just have to become a little bit more familiar with it, I guess. That there are places for math errors, but that is always true, so I don't think we can get away from that. We just have to be really careful in thinking about our positives and negatives. Those are usually the worst things here. You might want to take a moment and go back through this explanation. I know that this is a skill that is somewhat new for many of you, and it's worth looking at again. You can be assured that in class we will solve other quadratics by completing the square so that we all get a little bit more practice. But now I'm going to move on. Today is the quadratic formula, which many of you will remember. Works for any quadratic that's in the format ax squared plus bx plus c equals 0. The formula says that to find a root or a solution, x will equal the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Some of you may have seen this written as one big fraction, so I'm going to write it that way as well. That would be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And the big advantage to this, of course, is that it does work for every quadratic. There isn't one that can't be solved using the quadratic formula. Works for all quadratics. Disadvantages, math errors again, especially sign errors. So you got to be real careful with the SIGN signs. In this particular problem, A is 2, B is 5, C is 4. And as we substitute those values into the quadratic formula, we'll get x equals the opposite of b, so minus 5, over twice a, and a is 2, so 2 times 2, 4, plus or minus, under the radical, b squared, so 5 squared, minus 4 times a times c. All of that is over 2a as well, so over 4. Now it's time to do the simplification. Negative 5 over 4 plus or minus, and under the radical we're looking at 25 minus 4 times 4 is 16, 16 times 2 is 32. All of that's over 4. Keep on simplifying, you're almost there. Negative 5 over 4 plus or minus. On top it turns out to be the negative square root of 7, square root of negative 7 over 4. We already have dealt with that, so we know exactly what's going to happen next. Our final answer, x will be negative 5/4 plus or minus I times the square root of 7 over 4. The two answers, negative 5/4 plus, negative 5/4 minus, works for all quadratics, whether their solutions are real, imaginary, or not. The discriminant, which is the part of the formula that's under the radical, that is b squared minus 4ac. If we look at the sign on that, it'll tell us what kind of roots we will have. If the discriminant is less than 0 or negative, that means that we will have two imaginary roots. Remember, they always come in pairs. If we have the discriminant coming out to be exactly 0, that means that our two roots are both the same number. That is, we'll have one value or one root that happens twice. We'll talk about that a little bit farther in this course. If we end up with a discriminant that's above 0, that means that we have two real number roots. And so just by looking at the discriminant, we can kind of tell what will happen when we solve any quadratic equation. Ladies and gentlemen, that's the end of our lesson today. I want to remind you that we need you to look at the U-Try exercise for this lesson, lesson 7 tonight, and let's make sure we submit those before class in the morning. Thanks a lot and have a good night.